this presentation, I want to approach aquaponics from the view of using it as a business. And I will talk a bit about things that have been or are important in starting up a fish farm, because they also apply to aquaponics. And we'll talk about some of the difficulties with using or doing business with aquaponics, but also how some of those difficulties can provide new opportunities. So, a word beforehand, this presentation may contain quite a lot of personal views and opinions. Obviously, everything is open to debate, and well, we can do that during the presentation or afterwards. This little introduction happens. So, when we talk about aquaponics, there's a lot of different things we can talk about. We talk about aquaponic systems. We can talk about a lot of different setups, like coupled versus decoupled systems. Talk about different system configurations, different filtration systems, different fish-to-plant ratios. But now, I'm not going to talk about all of that. I want to talk a bit more about how to make it work. So, this is, again, things from the businesses that I have encountered. So, most of the aquaponic businesses that I've seen so far, some of them weren't even, you couldn't even call them businesses, but almost all of them have been on a relatively small scale. Some gave some ideas of the scale that we talk about on hydroponics. Obviously, that's a completely different story than what we've seen so far in aquaponics. In a lot of cases, projects were done with really low budget, so a lot of DIY stuff, or maybe using not the most optimal techniques, because there wasn't enough money available. In a lot of cases, aquaponic businesses that I've seen have been aiming for premium markets, so getting a really high price for your project because of the story behind it, because of the story behind aquaponics, healthy, balanced stuff. And well, in almost all the cases, most of the money came from the vegetable part. So some bottlenecks that are encountered for commercialization. If you start thinking about a commercial scale, so something that is comparable to commercial ROS or commercial hydroponic farms, there's obviously the issue of organization. Organization meaning licenses, permits, insurance, how to set up your business, how to take care of the risks of your business, of, for example, something going wrong with your fish, influencing your plants, who is liable for what, who is to blame, who has to pay in the end. There's obviously the issue of scale, because we're combining two industries into one. Basically, it sort of explodes in the scale of things, and I'll give you some examples later of how that works out. There's the issue of funds, obviously, related to the scale. I'll also talk about it a bit later, about how soon all the investments can get over a couple of millions easily. And there's obviously skills. You need people that know about a lot of different things. So talking about organization, as I said, licenses and permits is often a problem. You can get a license for one thing, but not for the other. For example, if you can get a license to do a greenhouse somewhere, you won't be able to get a license to use enough water, to pump up enough water, or something like that. It's often a very lengthy process to get permits to do a fish farm, or to take up water, or to discharge water somewhere. Process that can often take easily 5 years. So a lot of people already have lost their patience by that time. Something that we discovered on the farm in Belgium is insurances. In order to get a loan to do a hydroponics farm, you have to have a crop insurance. Yes. For example, this insurance against maybe like a power cut, or where you have not enough water, or you get a sudden disease, things like that. You have to insure yourself against that. At least that's the legislation in Belgium. You have to have that insurance, else you're not allowed to do the business.
How much does it cost?
I don't know.
Okay.
But in this case, on the project in Belgium, the insurance company didn't want to provide the insurance because they were thinking about using fish water. And they say, we don't know what's in the fish water, we've never done this before, we can't control it, so we won't give you the insurance. End of story. So now they're starting a really long project of proving to the insurance company that it is possible and that you're able to control everything, but it's going to be another 4 or 5 years worth of project before they can actually make the next step. Obviously, that's all related to the risks. As we've seen, if you have a disease in your fish farm or in your hydroponics farm, sometimes you don't have another option. You have to treat with something, which in an aquaponics facility obviously will influence the other components. You have to think beforehand about how we're going to deal with those risks. Who is taking on the risk? Who is going to be liable in what situations? And in general, there's a lot of corporate paperwork when working with this, getting the permits to produce and to sell food, or even to process food, all that kind of stuff. So on the scale, how would you determine the ideal scale of your business? There's a couple of questions you need to answer to get to that point. First one is you have to think about how much can you sell, where are you going to sell it, what kind of people, what kind of shops, and how much will you be able to sell what produce exactly. Then you have to see how much can you actually produce. If you can produce a lot more than you can sell, there's no point because you won't be able to sell it. And the next step is asking yourself, how much do I need to sell? How much do I need to be able to have a viable business? So with answering these 3 questions, you can get an idea of the scale of the business that you would need to have a viable business. So on the funds, very often in the past, aquaponics systems have been built with your own out of your own pocket. It's often very hard, especially in the last years, to get loans from banks. Banks will ask almost, if you ask for a loan of 1 million, they will want 1 million of collateral. So they try to minimize their risks. You can work with external investors, which is not always easy because you lose some of the decision rights in a lot of cases. They will pressure you to make fast money, and that's not how aquaponics or food production in general works. And there's different strategies that you can use. There's 2 strategies that they call burn rate or bootstrap. Burn rate is what they do a lot, for example, in the US and the UK. Basically, get a massive pile of money, hire the best people, and just go for it and see what happens. Bootstrap is a more continental European approach, where you start small and you work your ass off in order to get somewhere. But obviously, if you have a lot of capital behind you, you can achieve very fast growth in your business. And with Bootstrap, that will take you a lot longer to get to the same point. Obviously, the risk of burn rate is also a lot higher. To give you some indications, a very rough indication, an average fish farm producing 200 tons per year will cost around 2.5 million on investment. This is already a large sum of money if you have to come up with it by yourself. But a fish farm this size will allow you to produce about 1,400 metric tons per year of lettuce, as an example, which relates to a greenhouse of 3.5 to 4 hectares in size. I don't know the figures about greenhouses, we should have asked Tom, but I'm sure that a greenhouse this size will also...
metric tons.
Metric tons, yeah.
Metric tons.
So 200,000 kilos.
The ratio is 7.
So,
the ratio?
Depending on the species, obviously, but just to give you an idea about the scale of things.
Is it with tilapia, this one?
This one is based on an article from James Rakosi from the Virgin Islands. They did an article on the financials of their system.
On UVC?
Yeah, the UVI system, yeah. Obviously,
So it's tilapia.
yeah, this is tilapia. Yeah. You can obviously build cheaper tilapia systems, but as an indication, this is the scale of things we're talking about. A greenhouse from this size, I don't know exactly, but I'm sure it's going to cost more than 2.5 million. So your total investment is already more than 5 million.
And what RO?
Return on investment.
Exactly, return on investment time. The average in RAS systems is 7 years, if companies even make it to 7 years. Quite often they go bankrupt before they reach it. In hydroponics, what Tom said, it's easily 15 years, sometimes even indefinite, before they will make their money, start making actual profit. So these are all important things to keep in mind when you start a business. It's quite a different approach to like a fast-growing tech company or something. An important aspect, obviously, in running your business is the markets. The data in the previous slide from the article from James Sarkozy was based on the price of lettuce of 75 cents per head. I know the price in the Netherlands is now about 25 cents per head, euro cents, so it's a bit different. But there have been price fluctuations as low as 12 euro cents. So if you need 75 cents to make your business viable, and you're not getting 12 cents, then you're fucked. So it's important to look at the market prices, but also to look at the swings in the market prices. You can use it to sell in periods where there's a high demand and prices are higher. But if you don't take care of it, you'll be trying to sell your lettuce and nobody will want to buy it. You can easily have swings in market price of more than 100%. So it's quite a tricky business. About the skills, well, there's a lot of, as somebody practicing aquaponics, there's a lot of things you need to have some knowledge of. You need to know about plants, you need to know about physics, chemistry, fish. You need to know how to plumb and how to wire a pump. You need to know about marketing, about management, how to sell your stuff. You need to know about what materials to use. In general, you risk knowing a lot about everything, but never enough. So they call it a jack of all trades, but a master of none. One of the risks. So obviously, there's a lot of hurdles to setting up a viable aquaponics operation. But to give a few of the more technical ones. We've spoken before with Tom about the sodium accumulation. In fish farming, you need to keep your pH stable. Components that you use for that might again give problems with the pH of your plants. Obviously, the two different components prefer two different pH ranges. It's again the balancing act that Adrian talked about. The nutrient concentrations, which might not be optimal, and well, the balancing of components. Obviously, there's a lot more which we can discuss about later. But also some of them might be opportunities. You see the PowerPoint fucked up a bit here. For example, the nitrogen or sodium accumulation is an opportunity for feed production companies to produce low sodium feeds, which might be able to solve that problem for us. Same for not being able to use pesticides. It's a step towards organic production. Well, there's a lot of these opportunities that if you take a step back and think about it, you can approach them also as an opportunity. Obviously.
Low sodium. Don't fish need that sodium?
They need it, but different fish species need it in different quantities. And quite often now there's more sodium in the fish feed, especially if there's a lot of fish meal used in the feeds. There are ways where you can reduce it. Some of the technical challenges, which are more general, which I just wanted to point out quickly, in any system. So not only aquaponics, but also the separate things. It's important to consider energy efficiency, it's important to consider ergonomics, automation of things, redundancy and safety features. Obviously you want to maximize your space utilization, climate control, and obviously there's a lot of other things. I will go into these 6 things briefly. I won't go into too much because we have some time for discussion later. Talking about energy efficiency, talking from my experience in aquaculture, normally energy costs are about 10% of the total cost of an aquaculture facility. This is a general indication. Obviously, if you have to heat or cool your water a lot, this can be much more. Also depends on the intensiveness of your farm. Like if you have much more filtration and pumping capacity, you will use a bit more. But you can minimize the use of energy by efficient design. You can use gravity to transport water from one point to the other, and the way you design your pipework can have quite a big impact on the energy that you have to use to pump the water around as well. You can use efficient equipment. You can use low pressure pumps, for example, or very efficient heating. Obviously, insulation helps a lot as well. And one of the things you can do is recover the energy that you use. For example, if you have water leaving your system, there's obviously a lot of heat or energy in the water. You can take that water out and reuse it in your system. So, to give you an idea on that, you can use heat exchangers. Basically, you can see here there's a blue stream of water and a red stream of water, hot and cold. The warm water, in this case, leaving your system, the cold water coming into your system. You bring them in contact with each other, but you separate them with a metal sheet. Basically, by letting them flow in opposite directions, you transfer the heat from one water source to the other water source. That way you can reduce the amount of heat that you discharge, basically. This is a picture of, or a diagram of, a heat exchanger for water to water. You can also do it with air. For example, here, if you have the warm air from inside your greenhouse, you can let it flow through a heat exchanger with new fresh air coming in from outside. You transfer the heat from the air going out to the air going in. That way you can reduce the amount of energy that you have to put into heating. Some words on economics. It's always important to, or I always say it's important to think about what you're going to build before you start building a system. Think about how you can make it easy to work, like your layout. You can plan it so that you have a logical routine of work, so you can work in steps. You don't have to go from one side of the room to the other and then back and forth, but make it like a logical process. Some things to consider is, for example, you can minimize the heavy lifting that you need to do. Think about the surfaces that you're working on, that they're on a comfortable height. In general, we say that, for example, aquaculture tanks shouldn't be higher than 1.20 meters, because that's still a height where you can use a net and scoop the fish out. If your tank is like this high, you'll be working like this, and that's very uncomfortable and very inefficient. It's important to consider easy access, so not having really narrow hallways everywhere, but make it easy to work so you can actually turn around and work, or take a trolley in between tanks and stuff like that. All things to keep in mind when you're designing a system. Automation, there's a lot of things you can automate. Whether or not you should do it and to what extent obviously depends on yourself again. Some examples of things you can automate. Lights obviously is very simple. Temperature regulation, ventilation, cleaning of filters and stuff like that. Dosing of pH buffers or nutrient solutions. Alarms that tell you when something is wrong. You can have automatic feeding of your fish. All of this is possible up to more or lesser extent. To give you some examples, very simple, just a timer to switch on your lights on and off. The next step is a small PLC. This is a Siemens logo, which is very simple little computer to which you can program for simple tasks like some temperature regulations or some simple switches, or you can go very complicated and have these whole boxes with steering modules and everything. Obviously, there's what you're working on, the Arduino open source thingies. You can make it as simple or as crazy as you want. If you have a deep pocket, you can do whatever you want. In general, it's important to think about redundancy, and the question that you always have to ask yourself is what if, and keep in mind Murphy's Law, anything that will go wrong will at some point go wrong. I've had a lot of cases of clients or other people telling me like, oh no, this will be fine, this is supposed to last 5 years, we'll only run this for 3 years, so it should be okay. And sometimes it goes okay, sometimes after 2 days they come crying like, oh, everything broke and all my fish are dead. To give an example, when I was doing my thesis, I just arrived at the institute and I was supposed to work with some small salmon. They had been growing the salmon for 4 months, I think. And I came there and actually the alarm module broke down, had a short circuit, caught fire, and stopped the whole system, stopped because it was steering all the pumps. All the pumps stopped, all the fish were dead. And the second day I was there, I was scooping that fish. So even the alarm module, for example, is something that can go wrong. So you always have to think about putting backups, putting extra alarms, or putting really simple little things to stop a tank from all the water flowing out of the tank. Things like this. Always keep in mind what if it goes wrong, and try to solve as much of the problems as you can, or at least create some buffer. So a list of common faults. It's depending on obviously on where you are in the world. There's obviously the risk of loss of power, which the results are quite obvious that your pump will stop, your fish will die if you don't have an alarm or backup power supply or backup oxygen. Again, there's lots of ways you can tackle this problem. Under engineering is quite common. If you build a certain system, you don't know exactly what is the carrying capacity, and people throw in too much fish. Again, the fish can die. Using wrong materials. There's a fish farm in the US which was using like an old warehouse which had big wooden beams, and as soon as they put the water in there, the moisture in the air got into the beams lost their strength, the whole roof collapsed, fish farm stopped. So it's quite important to consider about what materials to use. Often it's cheap to use second-hand materials or repurposed materials, but you really have to think about if it's suitable and if it's worth the risk. Well, even your sensors that you're using as a backup, sensors can fail, or you can forget to calibrate them, so they can give you wrong readings. So you have to check every day if the sensors are still giving you correct readings. Or if your equipment can fail, you can get diseases. Human error is a very important one. I think most of us have at some point forgotten to close a valve or leave a hose running and filling up a tank, or flooding everything, or the bath or whatever, or leave the coffee machine on. It's always little things, but they can have quite big consequences. A lack of proper maintenance is also a very important one. It's so easy to think, oh, everything is running, so everything will be fine. At some point, it won't be fine. Talking about space utilization, it sort of speaks for itself. You want to increase the production per area that you have. Obviously, it relates to the price of the land. If your land is really expensive, you have to put a lot of energy into increasing your production. You might consider going vertical, but it's a trade-off because pumping water over a larger height requires more energy. Again, a lot of things to consider. Climate control, I think there's quite a lot on this, but I think I'll skip it because Tom dealt with most of it already. You know about the humidity and things. The difficulty in aquaponics is because a RAS system obviously has a lot of air exposed, or water exposed to air. Normally air coming from a recirculation system is really high in relative humidity, which makes it really hard to control the humidity in a greenhouse if they're in the same building. obvious solution is to separate the two and not have your fish tanks in the greenhouse. There's other technical things that you can do to control this, but I'm sure you can figure that out. So as a conclusion, there's a lot of different approaches you can take, there's a lot of different things to think about, and obviously everybody has different interests. So I understand that not everybody is looking at aquaponics as a way of making money. There's more idealistic approaches. Financial viability, as we've seen so far, is questionable. I'm sure there are ways where people can make it work, like for example the example on the UV islands. I hope the guys from Bonad will be able to make it work. I think there's a lot of opportunities, a lot of, whether they are in research or in development or in problem solving, there are a lot of problems to solve. But I would suggest all of you to play around and test and fail and keep on trying. I think that was it so far. Yeah, thank you very much for your attention.